Hello everyone. My name is Jnanesh and this is Group 8 from the S division who is here to explain the concept of single bus organization of data path in a processor with the help of my fellow mates under the guidance of our guide Lokesh Khedekar sir. So let us begin.
Before starting off with the process, we need to understand a few basic terms. PC or the program counter will point to the next instruction that needs to be executed. MAR and the MDR are the two registers that are used to communicate with the external memory systems. MAR is the memory address register and the other one is MDR or memory data register. Another component in this processor is the instruction register or IR, whose main purpose is to temporarily store the fetch instruction received from the memory. Below the IR is a set of registers RO, R1, R2 to Rn-1, which is used for programming purposes. In these processes, Y, Z and temp are special purpose registers that are used to store some value temporarily while the process goes on.
Thus, Y register receives its data from the internal processor bus, which is given to the multiplexer. After transferring this data, the value is incremented by a constant number. In this case, it is 4. This is the reason we have a constant 4. The last element, but perhaps the most important one that we need to have focus on, is the ALU, or the arithmetic logical unit, whose job is to perform various arithmetic and logical operations, which correspondingly have control lines that decide which operations are to be performed by the ALU. The ALU receives inputs from the various registers set on the other side, and this value is then temporarily stored in the Z register. These are the components included in the single bus organization of a data path.
Now let us take a look at how to execute an instruction. Step 1 is to fetch the contents of the memory location pointed out by the PC. The contents of this location is interpreted as the instructions to be executed. As we can see, IR is equal to the content of the memory location pointed out by the PC. Step 2. Assuming the memory is byte addressable, increment the contents of the PC by 4, that is, PC is equal to content stored in PC plus 4. Step 3 is to carry out the actions specified by the instructions in the IR. Note here that step 1 and step 2 is the fetch phase, whereas step 3 is the decode phase, execution phase, and or write phase.
Now that we have understand what are the basic components in the processor and the steps to execute an instruction, let us look at how we can execute an instruction. This can be achieved by performing one or more of the following operation in some specified sequence. Transfer a word of data from one processor register to another or to the ALU. Perform an arithmetic or logical operation and store the result in the processor register. Fetch the content of given memory location and load them into processor register. Store a word of data from processor register into a given memory location.